Okay, so here's another example of a voltaic cell. I got this question off of Quest A+, which is an excellent resource to try old diploma questions. So starting with this question, it is asking about electron flow and anion flow, and that would depend on which anode is your cathode and which, I'm sorry, I should have said electrode. Which electrode is your cathode and which electrode is your anode. So what we're going to do first is determine that. So let's write down what we have reacting. So we have copper solid, right? We have that one electrode, and we have copper 2 positive in solution. We also have NO3 negative in solution. We definitely would have water present. And then on the right hand side, we have a copper electrode, which would be an inner electrode. And you have some silver ions, and you also have some more NO3, which we've already accounted for. Now, say in this porous cup, that is going to be your salt bridge, and we'll move on from there. So now going through this, you want to identify your strongest reducing agent and strongest oxidizing agent. So remember, for strongest OA is at the top of the chart, and then you go down. So what I'm seeing here for being our strongest would be that silver ion, which is right here. So that would make silver Ag positive our strongest oxidizing agent, and oxidizing agents undergo reduction, and that happens at the cathode. So that would mean your carbon, that inner electrode, is acting as your cathode, and just to verify, copper then would have to be your anode. So if we're looking for our strongest reducing agents are strongest from the bottom right, and then they get weaker. So the first one we are going to see is copper solid. So that would make this our strongest Ra, and that would undergo oxidation, and oxidation happens at the anode. So we have our anode here, and our cathode is here. So cathode. So now in terms of the rest, once you have identified it, all your cells will work the same. Your electrons always flow from your anode over to your cathode. Because our OA is higher on the table than our Ra, this would be a spontaneous reaction, and that would also mean you have positive cell potential because it would generate electricity. And then in terms of your salt bridge, so actually let's go through this already. So the direction of electron flow, this first one from the carbon electrode to the copper, that's not true. The next one, same thing, not true. So we've narrowed it between C and D. And then when we want to talk about anions, so the anions would be from the porous cup, our salt bridge. We'd have positive cations and then those negative anions. Now with our anode, as your copper solid breaks apart, and it would become, so the copper solid would become your 2 electrons plus 2 of the copper ions. I don't know why I wrote 2 there. There's not 2. That's going to decrease in mass, and there's going to be a buildup of copper 2 positive because that's what's going to end up in solution. Now, to neutralize that charge, the negative anions from your salt bridge will come on over and flow towards it just to keep our whole solution neutral. And then the opposite would happen on the other side. So when it's talking about anion flow, your anions are flowing towards the cathode, which is copper. So your answer here would be C. So as always, I hope you found this helpful. And if you did and you made it this far, please subscribe. And if there's any other video I can do for you, please just let me know. Thank you for watching.